Hello everyone, my name is Chetan Arora and I'm going to present NARCIA, an automated tool for change impact analysis in natural language requirements. This work has been done jointly with Mehrdad Sabetzadeh, Ada Goknel, Lionel Brion from the University of Luxembourg, and Mr. Frank Zimmer from our industry collaborator SCS Techcom in Luxembourg. Here's the agenda of my presentation. First of all, I'm going to discuss the motivation behind implementing this tool, followed by the challenges that this tool aims to address. Next on, I'll present the overview of the tool where I'll briefly discuss the individual steps in the process implemented by the tool. After that, I'll show you our tool in action where I'll walk you through different user interface components of the tool using two example user scenarios. And I'll conclude this presentation with the results from two industrial case studies we conducted using NARCIA. Here's the motivation behind building NARCIA. In a software development process, requirements changes are inevitable, and if left unmanaged, these changes can deteriorate the software's quality. Hence, it's paramount to analyze the impact of requirements changes on other requirements to maintain the sanity and consistency of the requirement specification, which is one of the most important artifacts in software development lifecycle. However, it's really difficult, if not impossible, to do a manual analysis of the changes at a reasonable level of quality, and is especially cumbersome when the requirement changes are frequent and the number of requirements is large. So we decided to implement an automated solution that is NARCIA, which stands for Natural Language Requirements Change Impact Analyzer, for analyzing the impact of requirements changes on other requirements. To develop such an automated solution, one must overcome certain challenges, with the first one being the prevalent use of natural language for specifying requirements. Natural language is very abstract in nature, which can make it really difficult to build automated solutions around it. To understand the further challenges, let's first have a look at these example requirements. These requirements have been picked from a requirement specification concerning a nuclear plant's safety regulations. So the next challenge is that to conduct an effective change impact analysis, an automated solution needs to capture the changes in the requirements precisely. Let's consider an example where R1 is changed and the word sixth is replaced by fifth. The change itself does not convey much information. That is, sixth being changed to fifth does not make much sense until considered at a semantically meaningful level. NARCIA overcomes this challenge by capturing the changes at the level of phrases. Hence, it's much more precise and clear if we say that the sixth degree of defense has been replaced by the fifth degree of defense instead of saying just sixth has been replaced by fifth. The next challenge is that of capturing the change rationale precisely. This is important because the change itself, even if captured precisely, is not enough for accurately performing change impact analysis. It requires capturing the basis on which the change was made. Let's consider another example change in R1 where the phrase nuclear accident alarm is replaced by the phrase nuclear hazard warning. If the rationale for this change is to globally rename nuclear accident alarm to nuclear hazard warning, then all the requirements concerning alarms or signals on nuclear accident will be impacted. So in this case, R2 will be impacted. Alternatively, if the change rationale is that the nuclear hazard warning is a new protection level concerning the leak prevention of the ducts, so that preventive actions such as leak prevention of ducts can take place at an early warning rather than after the accident alarm, this would impact R3. NARCIA facilitates capturing the change rationale in the form of a propagation condition using an intuitive user interface. This will be discussed later on in this presentation. We further researched to see if a relevant tool already exists that provides the intended functionality and at the same time overcomes the challenges mentioned. The state of the art only showed approaches that concern change impact analysis from requirements to other artifacts such as design or source code or test cases. Additionally, these approaches heavily rely upon the availability of explicit requirements relationships to perform change impact analysis. Such artifacts are usually not available in the early stages of development, and require an extensive effort for creating and maintaining them, as all this needs to be done manually or with limited automation support. So we implemented a tool named NARCIA that performs requirements change impact analysis and overcomes all the previously mentioned challenges. That is, it uses natural language requirements, it captures the requirements changes precisely, and also provides intuitive means for specifying the change rationale. And above all, it does not require any additional artifacts such as requirement relationship matrices to function. The requirement relationships in NARCIA are automatically captured that manifest themselves within the phrasal structure of requirements. Here's the overview of the process implemented in NARCIA. The process begins by a requirement analyst specifying the natural language requirements, which are uploaded in NARCIA and are processed for detecting phrases in the requirements. As I discussed earlier, it is important to capture the changes at the level of phrases. These detected phrases provide a perfect abstraction for automatically analyzing natural language text. Then next on, the textual similarity is calculated between the phrases. The similarity is both syntactical and semantical. Syntactical degree captures syntactic variations of the terms in text, such as sixth degree of defense and sixth defense degree. Semantic similarity, on the other hand, captures the synonymous variations of terms in natural language text, such as safety, defense, or protection. Next on, if the analyst introduces a change, the change is processed to capture the changes made at the phrasal level. In the next step, the change rationale is specified by the analyst in the form of a propagation condition using the phrase level changes. All the outputs of the steps by far are used by the last step, impact likelihood calculation, that computes the likelihood of each requirement in a specification to be impacted by the change. The result is a sorted list of requirements, sorted based on the likelihood of being impacted. Now moving on to the demo of NARCIA, where I'll walk you through the process I just explained, and I'll also show you the corresponding user interface components using an example usage scenario. Here's the NARCIA user interface, and this is the first screen in NARCIA with this table containing the saved sessions of the previously processed requirements in NARCIA, containing the output of phrase detection and the similarity calculation steps. When you click on any of these rows, you can go on and apply the changes for any of these requirement specifications. But for us, we are going to upload a new requirements document from scratch. Let's go to the upload screen, and here you can upload the requirements. So these requirements have been uploaded, and now we initiate pre-processing, which is essentially executing the phrase detection and the similarity calculation steps. So the pre-processing is now complete. Now we can go on and apply changes in the requirements. So if you click any of these requirements to change them, so here's the change application screen where you can apply a change or you can delete the requirement altogether. So let's just make a change as we saw in our presentation. So nuclear accident alarm being replaced by nuclear hazard warning. And then we accept the change. This brings you to the change propagation specification screen with the original requirement here and the noun phrases and the verb phrases highlighted, and also the change requirement with the new noun phrase here and the other noun phrases and the verb phrases in the requirement highlighted, and also the results from the phrasal differencing step where it tells you that the nuclear accident alarm phrase has been deleted and has been replaced with the new NP, nuclear hazard warning. Now on this screen, one needs to specify the change rationale in the form of a propagation condition, and you can drag and drop these phrases from here to these clause boxes, which are basically ANDed together to form a Boolean query from the phrases. So suppose our change rationale is that we wanted to globally rename nuclear accident alarm to nuclear hazard warning in our requirement specification. So we just drag and drop nuclear accident alarm here and then analyze the change impact of this change. Now this screen shows you the results from the change impact analysis with the propagation condition mentioned here and the list of requirements sorted based on the impact likelihood scores. So it tells you that R1 and R2 will be impacted with the likelihood of 1 and R3 will be impacted with the likelihood of 0.77 here. Let's just consider one more complex example and moving on to another session of NARCIA. Now we see that on the save session screen we have one more entry regarding the demo example which I just showed you. Let's just load one of these sessions. So these are the requirements in the specification. Let's apply change in one of these requirements. So it brings you to the change application screen where we see the original requirement, which is a WASP application shall be able to establish a phone call connection using the 3G platform via the WASP platform. And here where we can apply the change, let's say we want to add a functionality regarding video chat connections in our system. And video chat connection using the 3G platform. And now we accept the change. This brings us to the change propagation specification screen where we see the original requirement, the change requirement, and the output of the phrasal differencing step, which shows us a new noun phrase has been added, which is video chat connection. So let's just specify our propagation condition based on the change rationale, which was that we want to add a new functionality of video chat connections to our system. And the system is WASP application. You can drag and drop from here, or you can also have this option of autocomplete from this drop down containing all the phrases in the requirement specification. So say one of the syntactic variation of WASP application is WASP platform, and then we have a condition regarding 3G platform and anything to do with connections should be impacted. So all three clause boxes will be ANDed and the variations here will be odd in the Boolean query. Let's just analyze the change impact. So this shows us the propagation condition, so WASP application or WASP platform and 3G platform and connection. And these are the potentially impacted requirements with the impact likelihood score here. So the first one is the requirement which changed itself, and then it shows us this requirement will be most likely impacted, which has to do with communication services in the WASP platform. So we know when we add a video chat connection, anything to do with communication services in our platform will be impacted. Getting back from the tool demo, here are some details about the empirical evaluation we conducted using NARCIA on two industrial case studies. The first case study is about a satellite ground station simulator component with 160 requirements and 9 change scenarios. The second case is about a mobile context-aware platform with 72 requirements and 5 change scenarios. One of the most important points regarding usability of the tool is that user should know when to stop looking for impacted requirements in the sorted list produced by NARCIA. That is, after what point in the sorted list of requirements one is not likely to find any impacted requirements. We provide such guidelines in NARCIA based on the differences in the consecutive impact likelihood scores in the sorted list. So you have such a delta chart with peaks, and when you see a highest peak, you move on further from there till you see another peak with at most 1/3 height of the highest peak. So H max divided by 3 here. So immediately after this peak, one should stop inspecting the requirements. We do not consider the last peak here, and more details about it can be found in the approach paper on the website. It must be noted that such a delta chart is not presented to the user and is automatically computable. Next, we wanted to evaluate the effectiveness of NARCIA. The first measure of effectiveness is the futile effort analysts would have to spend analyzing the requirements based on the guidelines from the last slide. The futile effort is essentially the total number of requirements recommended by our guidelines minus actually impacted requirements. In both case studies, we found that the extra effort or the futile effort was a reasonable 1 to 8% of the total requirements, except one case where it was 45% of the total requirements, but could have been easily improved with the more precise propagation condition. The next measure of effectiveness is the number of missed impacted requirements. So, based on our evaluation, we just missed 1 out of total of 106 impacted requirements across all the change scenarios in both case studies. And the missed case is due to a limitation of our tool where we miss out on tacit relationships in requirements, and addressing this limitation is a part of our future work. I would like to thank you for your time you spent listening to this presentation. If you have any queries, you can contact me at chetan.arora@uni.lu, and more details about the tool are available on this link. Thanks again.